Hey, hi everyone. Welcome to the second video of the series. In this video, we will talk about how to build our first agent. You know. Before doing that, let's see what all the setup we need. We'll be using Visual Studio Code to do all the building, and basically we need Python, and then we'll be using UV package manager to installing. And first what you need to do is like you need to create a virtual environment and install these two packages. One is the OpenAI, and this OpenAI agent is the package which is the OpenAI agentic framework using which we can build the agent. So this is the first thing we need, and we need to activate the virtual environment also. I forgot to you know add this environment. Okay, and as I said, like in my repository over here, so if you go to setup dot this one, right, so all the setup instructions are there. What we need, like Visual Studio Code, which already I have. Okay, and I have Python 3.12.3 is installed, and I had also installed UV. So you can go over here to install UV. Very simple steps to install UV, and UV is nothing but very ultra fast package manager, like similar to pip, but more faster than that. And first what we need to do, like we need to create a virtual environment. So we create a virtual environment and then activate it, and once you activate it, you install the packages. So it's UV pip install. We need, as I said, OpenAI agents and mainly OpenAI, and we need python.env. This is to load environmental variables and some other libraries which we need during the course, different use cases. And particularly during one use cases, we need some further installation. This is optional for now, or if you want to do when the use cases, then only we need to do it. And next, as I said, like we need to go to OpenAI key, do the API key setup is needed, and you need to install the OLlama and need to pull these two models, GPT OSS and Llama 3.2. Okay, so that's the basic requirement for the setup. So that's what we need: OpenAI, sign up and get the key. And I will show you like how to create this .env file and store the API key. And as I said, you will get $5 free credit, which is enough for this tutorial. And I'll show you like how to use local OLlama model. So we need to download and install OLlama and pull this to a model. Okay, so these are the basic bare minimum setup is needed. So if you're stuck anywhere, you please ask me for comment, put the comment, so I will try to maybe create a other video dedicatedly for this installation step. But I think these all are common thing, but and anytime you can take help from ChatGPT or Gemini to solve these common issues if you encounter. Okay, so I assume that these all are the setup already you have, and we'll go to the next step, like how to build the agents. So in my course material, if we'll go, like I have started like 1 2 3 4 like this, so you can go serially. So first we'll go like building a simple agents that we will see. Okay, but before that, as I said, like first we need to create and get an API key and create a .env file. Okay, and put it in the repository. Let me show you how I have done it. So this is I cloned this repository. You will see a folder, basics folder, and this, you see I have created a file .env, and it has to be exactly the same name .env. And if you click it and you just put OpenAI underscore API underscore key and equal to, and don't give space anywhere, and directly within double quote you can give the API key what you get from this thing. Okay, and so basically we are storing this key in this variable, and during the code we will load those environment keys, the open key in our environment. Okay, so that's the first step we need to do, like get the key, store in this variable in this format, OpenAI key equal to your key here. Okay, so now let's see how to build an agent. So 3 steps process, that's all. First you need to import the library, and basically we need these two modules from Python. One is the agent, A capital, and runner. This agent is to create an agent, runner is to run the agent, 2 steps. Okay, so first you import all the Python libraries. So from agents, import agent, runner, and trace. Trace is like, I'll tell you what is for traceability we need it. And then you call this function, this agent function, and give some name to your agent, and the instruction is you are a joke teller, right? I told, right? So an agent is equal to LLM, the brain, and the system prompt. That means what that agent is. So that's what you are defining, and this parameter you pass instructions is the instruction to the agent. There you are telling that you are a joke teller, or you are a developer, or you can do this and that. That's called the system prompt. You pass in this parameter, and what LLM model, the brain, so you can use OpenAI model, or you can use Gemini model, those kind of thing, what model you want to use. So that's where the three simple step: give a name and provide the instruction and pass the model, and you create this agent. So your agent is created. So first is like import the library, define an agent, and we will see like this, as I said, the other component out of the 6 component, right? So we have only given 1 and 2. I will tell you like later on like how to give 3, 4, 5, 6, but for now using just only 1 and 2, that means the LLM and prompt will be able to create a very simple agent in an agent. So let's call this agent, and simply you use runner.run, and you take a query, what question you want to ask to the agent, and you call this runner.run and pass the agent the first argument and what query you want to ask. And important thing, like this runner is a asynchronous function. In Python, asynchronous function is nothing but, see, you are sending a request to the agent and it may take, let's say, 1 minute, 2 minutes to complete, and so that's why you have to wait for the result. And meanwhile your Python can instead of continuously waiting for that task to happen, it can do something else. So that means synchronous. This is not asynchronous, this is asynchronous. So that means let the agent run in the background, but your main Python thread can do some other stuff as well. So that's where to call such functions, since the runner.run is an asynchronous function, you just have to add one more keyword here, await, before calling. So all this agenting framework are mainly, if it is Python, they are asynchronous based. So we have to use this async way of working. Okay, so let's see, go to the our first one, build simple agent. So as I said, I have created this file .env and it is there in my folder, and I have put my OpenAI key over here, and it's kind of password kind of thing. You should not you disclose to others. So now let's first load this environment. Okay, so from this .env package, we are importing load .env. So basically what this function will do, from this file it will load that the key value in our environment. So once we run this, basically you should get an output called true. That means the key is loaded successfully. If it is false, means it is you are not able to find that environment file. Okay, so you should get an answer called true here. And basically after doing this, in my environment now I have this key available. So that means I don't have to specify this key again and again within my code, because it's already loaded in my environment. Okay, so now let's load this environment libraries, basic Python, from agents import agent and runner. This we need for to create an agent or define this to running. Okay, and this trace is optional. Okay, I will tell you, I will just remove this for now. Okay, and this OS I need it for some other purpose maybe. So now you see create a basic agent. So here I just put a tab here, my bad, sorry. Okay, now create a basic agent. So here I'm passing name, instruction, and I'm using GPT 4.1 nano model, is little cheaper, so I am using that. So now create an agent and then running. So basically here I have defined a query. So tell me a joke about a software engineer who is an autonomous AI agent. This is the query, and now I'm calling this runner.run, and first is I'm passing this agent to which I want to interact and what query I want to ask to that agent. So 2 steps, so agent and query, and then runner.run, and then you put a keyword called await, and now this will run that. What it will do is now it will send this query, and this it will go to call to the OpenAI, because we are using their model, so it will query there, it will hit their API, and there all this everything, the answer will happen, it will come back and it will get the results, and these results we are and contains many information of which we are interested more into the final dot output. So let's run it. So what will happen now, as I said, it will now send the request to the OpenAI. So now you got a response very easily, like, so this is how you are now chatting with a single command. So it gave some joke, okay, because it's a joke teller, because I have told it, right, you are a joke teller. So that's all, 3-step process. Now we will see what happened in the OpenAI. So if you go to your OpenAI over here, right? So here on the left hand side, you will see something called logs. Okay. So this should be platform.openai.com. Okay, /logs. Just remember this, otherwise you can do that. And you can go to our traces over here. So now this the see, I have tried a lot of things, that's why you will see so many other things, but you will see on the top like the first one, agent workflow name. So here we are calling an agent. The agent name is Jokester because we have given the name over here Jokester, and this is the API it had hit. So if you see over here, this used this model GPT 4.1, this model, and it consumed a total of 78 token. That means total I asked some question that is about 28 token, and the output what I got is about 50 tokens. So for I will be paying for this many token I used. Okay, and yeah, so you see this is the first information, that is you are a Joktel. This is the system prompt. Okay, this is what defines that agent. Then the next question was the user asked. Okay, this is another tell a joke about this one, and the output what I got. See, the input was 28 token and output was 50 token. So this is what 3 information of the system prompt and the input, and you got the output. So whatever you do, everything automatically stores in the OpenAI traces, and you can trace what is happening behind the scene. That's the good thing of using OpenAI Agent SDK work. So if you see, the code is very simple, right? So you just import 2 library, agent and runner, define an agent in this one single line with the 3 parameters, and then you just runner.run and you wait the result. Okay, so this is what we are interacting with the agent in non-streaming mode, because see, I call this one and everything finished. After that I got the output. Okay, it did not stream kind of output, but there is a way we can use something else from runner by to stream the output. Okay, so so the first thing we finished, we created a simple agent in the non-streaming mode. So we imported the library, we defined our agent, and we called runner.run, and first argument is the agent what we created and what query we wanted to ask. So now next we see same thing, we just now need to do the streaming mode. Let's ask in the streaming mode. So that means agent when we get the output, it will stream it. So for that, instead of using run, we have to call run.stream. Okay, and there is some boilerplate code is there. I'll just tell you what it is doing. Okay, but before that, right, let's just focus on the trace. Okay, so this command automatically, we did not do anything trace. By default it went to OpenAI do the trace, right? So now you can also give some custom trace name. So that's where you need to import this something called trace. So that's what I will be importing from agents import trace. So I am now importing this trace module, and now I can say with trace telling a joke. Okay, so let's see, and now I am simply calling it. I have already defined the agent, I don't have to redefine it. Just while calling I can give a trace name, so that it will not it will come back over here. So here you will see the name will change. The name got changed. Instead of simple default name agent agent workflow, now I got a trace name called telling a joke. You see, same response we will get, but now at least by the name you can change. So you simply say with trace, same thing what we did before. That's all. Alternatively, you can also define a unique ID. Just see, now from the agents there is some module called gen trace ID function. So you call that function and you get an ID, and basically if you see, right, the trace ID what is generated automatically is here. So basically you can instead of OpenAI generating this ID, you generate it using that. So that's all very simple, nothing else. And then I'm using this one here, and so you see now this got a trace ID generated 1459. So if I click here, so it also opens okay the trace here. Okay, so this is a separate trace. Okay, so that's how you can do. So that's all. I mean, but I don't want to use this one because like let's go with the default one, what the trace we get. Okay, So now we can, as I said, we can run the agent in a streaming mode as well. Okay, for that code is very simple. Okay, so we just have to import one module, that is from OpenAI responses, import this response text delta event. Okay, so what it does is like, so here we have defined our agent, right, already. So instead I am not using now the joke one, I will be now using some real one. So let's say here I'm creating the agent saying that the agent name is clinical expert, and I'm giving an instruction that you are a clinical expert in genetics, and again I'm using the same model. So now here I have defined my agent, and this is my query I'm asking to the agent. I will be asking, tell me about ACMG classification of genetic variants, and instead of runner dot run, I have to use runner dot run underscore stream. And again same, you pass the agent and what query you want to ask, and you get the results. Now basically this is now the you got a stream result object. So now from result you have to stream, call this function stream events using a for loop. For every event in the streaming, if the event is basically raw response event, basically if the event is a raw respond from the this thing, from the agent, and if it is a if there is some text delta present, delta means like, because it is streaming, right, let's say 10% stream, that means 90% streaming is still there and data is there. That means if some delta is available, then basically you are printing it and you are doing something. So don't worry, you can copy paste this code and it will do that. So let's try this one. So basically now I have asked a question, tell me about ACMG classes. So now see, it is now streaming the result. So it looks like more streaming, right? It did not got all this thing, right? So now let us go back here. Now let's go back to the traces and see. Now I did not give trace, right? So we got the default name agent workflow. Let's go with that. But now this changed, instead of jokester, because the name what I gave is clinical expert, right? So the agent name comes here, and so far we have not used any tools hand off, so that's why this will be 0 0. So let's go back, what happened here. So now it called this response. Now you see again the model is this one. So for this one we consume total 544 token. That means 27 was my input token, but the output was very large, right? So that's why you should also ask a question there, can you summarize in 2 lines, 3 lines, then it will save some cost. But yeah, so you see the you are a clinical expert, this was what the system prompt, right? So which we have defined here, and then this is the input, the query what I asked him, the agent, and the output what we got is this is the output what we got. See, all this ACMG classification detail we asked. Okay, this is how the streaming output works. Okay, but third way which I like most is you can create a chart interface as well with the agent. Okay, so for that we can use something called gradio Python library. Within 2-3 lines of code we will be able to create a very chart interface nicely. That's what I will be showing. So you can import the library, define an agent, and run an agent using gradio. So to run that, right, so we need to define a chart function and then call the gradio app. Okay, so let's do that and clear all the output. So now we did the streaming, we did the non-streaming. Let's do something else, that is chart agent. Okay, so for that we can use the gradio chat, and if you want to know more about this gradio, right, so gradio is from Hugging Face, they have developed it, very nice UI. Within few line of codes we will be able to do nice UI, and they have something, a function called chart interface, using which we can build chart interface very nicely, and something like that it will come. Okay, very nicely it will come. We'll do that. And two-step process, whatever we did here, right, this, right, what is that, this define a query and runner dot run, this one, this just copy these 2 lines and put it inside a chart function. That's all. So see, I am creating a chart function. I will tell you, just for now, just see these 2 what we did before, right? Await runner dot run, the agent, and the query. So here query is nothing but the message parameter, and you store results, and you are just returning to the results dot final dot out. So basically this is, you are defining a function, chart function, which takes the message is nothing but query what user will ask, and also you are passing the history as well. It takes the history, but for now the history is not enabled by default. Okay, and and here you first define a chart function, and now using this simple two line of code, you first import this gradio a gr and gr.chart interface, and you pass this first function chart, and you can give some title and description and launch it. Okay, so now what will happen, this will use this gradio module to create a very nice chart interface using which we can interact our chart, agent. So basically what is happening, in every time it is calling this one, this runner.run every chart interface. Okay, so let it run. So it ran it. So let's open in our this one window. So you see it's nice chart window opened. So you can talk him, hi, I am PB, So now what will happen, it will go to, let's go to traces here, right? So let's go to traces here. So I got an answer, hello PP, how can I assist you today with genetics? Why did I ask? See, that's what it responded, right? Because our system prompt was that you are a clinical expert in genetics. So that's why the agent knows that, okay, he's a genetics expert, right? So that's why he responded me, even if I said him, hi, I am PP. So he responded that, how can I assist you today with genetics? So that's what the system prompt defines what that agent is all about. So let's go back to traces here and see what happened here. So this is my agent workflow. I call this API, and you see the system prompt is, you are a clinical expert. I ask, hi, I am PP. Hello PP, how I can assist you with genetics? So what happened behind the scene when I did this, I asked this query. So what happened in the code, this happened, right? That means this first function got executed one time. So that means I got the message is hi, I am PP. This came, and I called the same logic what I showed above, right? Then this got passed to the OpenAI, that means agent, and I got the output, and that is got responded back, and it is shown in the chat window. So now let's ask an interesting thing. Okay, what is my name? So now you will see, I'm sorry, I don't have access to your personal information. So that means what happened here, even if I'm using a chat interface, the conversation is gone. That means this particular so far what we built, this agent, it doesn't have any memory associated with it. That means every time I'm calling the second time, what is my name, previous history is lost. Okay, so now let's go back to traces for this, what happened here. Let me refresh it, and so I'm going this traces here. So let's go to this response. You see, this is system prompt is there. Now the input is what is my name, and it will say that, hi, I'm sorry, the output. So that means every time we are calling the chart function, it's a new thing. To overcome that, there is two tricks. One trick is like, you can simply append, I have uncommented it. So every time you add this history, as I said, this history is nothing but all these things you see on this UI. So we can pass that parameter to this message, add the message. That means first time when we are interacting, hi, I am PP, this output. So next round, this plus this plus this, all three will go to the agent, and you will get answer this one. So now the next time if you are chatting, 1, 2, 3, 4, 5, 6. So all this chart history will be doing that. So let's do one thing. Okay. So now let me close this one. Okay. And let's rerun with this now history is at it. So every time my message got update. Okay. So let's rerun this one. Okay. So now it is now creating another agent. So hi, I am PP. This is my first query. So let's come back here, traces. So let me refresh it again. Okay. And I got response, hello, how can I assist today with genetics? Same response I got, right? So now you see, this is my first system prompt. Query is only this one, and this is the output I got. So now I am asking, what is my name? I think it answered it, hello PP, how can I assist you today? See, now it remembers. Okay, so let's see what happens in my second call. So if you go back to traces, let's see. So now my query input got changed. See, the input is now the system prompt remains same. Input, see what is my name, context is what, the role, user, metadata none, this is hi I'm PP, and assistant is saying that metadata, hello, how can I assist you today with genetics, like that. So this was the see, I'm updating this message, right, every time message, and context was the history. So that's why if you see, right, message is this one, what is my name, that means the second query, and whatever was there, right, this is the history I'm attaching. And now this all goes to the agent, and now agent responded this one. But see, this is so complex, right? So this is not the way we should do it. Then that's, I'm just commenting it, and that's where the next session something is called so we can use something called in OpenAI, we can provide memory to the agent using sessions. So that we will see in the next video. So just I will summarize what we did. We created an agent in 3 simple steps. So step number 1, import all the libraries, and basically we need from agents, agent and runner. Then you define an agent with 2 line, and 1 line, 1 command agent. You pass the name, the system prompt, the instruction, and what LLM model you want to use. Okay, and then you can create a query, and you simply call runner.run agent and query, it will do the rest. And then we saw the non-streaming mode where runner.run, and the streaming mode, and then the chat mode, 3 mode. But from now onwards we will be using chatting mode, so that it would be more easy UI you can see, but you can use any of this mode to do that thing. Also we saw tracing, you can custom your tracing as well, give some unique name or trace ID, also we can generate that, and everything is there in this code over here. Okay, and we also see how we can use the memory. So every time what you talked with the agent, so next time you add that whatever the conversation you had in the past, attach with your query and pass it to the agent. So that's how the memory works actually. But there are some better ways called something called sessions that we will see in the next video. I hope you liked it, and I will see you in the next video. Thank you so much. Bye.